Hello everyone, my name is Vivin Abram, and in today's video we are going to talk about different properties of charge. So basically we'll be talking about three different properties of charge. Number one, the additive property of charge. Number second, the conservative property of charge. And number third, the quantization property of charge. So let's get started with the first property, that is your additive property of charge. Okay, so what does additive property of charge mean to us? First of all, let's assume that we have a body A. Okay, let me just draw it as I say. Let's say I have a body A. So this is a body A, right? And let's say it has some charge Q1, right? And I want to give some additional charge Q2 to it. Let's say there is some Q2 charge and I want to give this to this body A. Okay, so additive property of charge says that the total charge on the body A after this Q2 charge is given will be simply the algebraic sum of Q1 and Q2. That is, the total charge on body A will be simply equal to the algebraic sum of the charge of it has Q1 charge and also the charge that you have given. Total charge will be equal to Q1 plus Q2. So let me just take a simple example. Let's say I have a body. Let's say it has some positive charge, a lot of positive charge, and let's say it has some 10 coulomb charge. Okay, 10 coulomb charge is a huge charge, but I'm taking it for example's sake. Let's say it has 10 coulomb charge, and let's say an additional -4 coulomb charge is given to this body. Now according to this additive property of charge, what will be the total charge on the body? Very simple, it will be Q total will be simply equal to Q1, and let's say this was your Q2, right? So Q1 plus Q2, so Q total on the body will be equal to 10 coulomb is your Q1 plus minus of 4C was the charge Q2 that is given to the body, right? So this will be simply equal to 6 coulomb plus of 6 coulomb charge will be the plus 6 coulomb charge will be the total charge on that body. So I hope that is understandable. That is all about additive property of charge. Okay, next, second property, that is charge is conserved in nature. Now what does that mean? It means that in an isolated system the total charge is always conserved. Now what does that mean? It means that in an isolated system you cannot create or destroy charge, right? So very simply, let me just write there, right? It means in an isolated system, total charge is conserved. Now what does that mean? So see, during nuclear processes, for example, let me take an example of beta minus decay. So in beta minus decay is actually a nuclear process, right? So in beta minus decay, what happens, we'll be having, so let's say, let me take it as an isolated, so it's an isolated system, right? Okay, so in beta minus decay, what happens, a neutron which does not have any charge, right, but it actually converts into a proton and a freshly evolved electron, right? So now neutron is, we know neutron is neutral particle, it does not have any charge, but it converts into proton plus electron. So proton has positive charge and electron has negative charge. Lucky for us that proton has plus E and electron has minus E, right? So if I consider the total, so you guys can see here neutron was, the total charge was 0. Here if I calculate the total charge, plus E minus E, this will come out to be 0. So in a way, in that system the charge is conserved, right? Okay, we can take one more example. One of the famous example is pair annihilation. It is a process in which, okay, let me explain. So we'll be having an electron E minus and we'll be having a positron. Positron is the antiparticle of electron. Okay, so what happens, they come together, they collide and they destroy each other. They collide, destroy each other, and pure energy is formed, right? So electron had, okay, so we can actually find out if this charge is conserved property is verified or not. So here we have pure energy, so E minus, so we can see initially it had electron and positron in the system, right? So the electron had minus E charge plus positron is an antiparticle, so it will be having so if electron has a negative charge, positron will be having positive charge, right? So it will be having plus E charge, right? So total charge of the system is actually 0. Yes, and in the other part, the Q final, in the other part we can clearly see its energy does not have any charge, right? So at the end there is no charge, so Qi is equals to Qf. That simply means that your charges are conserved, right? Charge is conserved. So this pair annihilation is one of the very good example of conservative property of charge. I hope that is understandable, right? Okay, let's move forward. That is, charges are quantized. Now what does that mean? The total charge on a body is the integral multiple of plus minus C. The total charge on a body is integral multiple of plus minus C. Okay, now what does that mean? It means that if we have body A, if we have body B, right, first thing that we have to keep in mind is the transfer of charge is in the form of electrons, right? So transfer of charges will be in the form of electrons. That is the first thing that we have to understand, right? Okay, so according to this property, the total charge on a body is the integral multiple of plus minus E. So if you want to transfer charges from body A to body B, so this will only happen in the form of electrons, right? Now again, there is a restriction. There is a way of transferring. You cannot transfer, okay, from body A I can not transfer 1.2 electron, right? Okay, one more thing that we have studied in the previous videos, that electron has a fixed charge, right? Electron has minus 1.6 and 10 to the minus 19 coulomb charge, right? It is fixed, right? Okay, so you cannot just say, okay, I want, okay, the body B cannot say that I want 2.5 electron or I want 3.5 electron, or it can only take the electron in the integral form of plus minus E. It can only take electron in the integral form of plus minus E, right? You can give 1 electron, a body A can give 1 electron, body A can give 2 electron, but body A cannot give half electron. Body A cannot give 3/2 electron, right? It must be an integer, right? So what does that mean? It means that for a positive body, the electron will be in the form of n times of E, right? Here n is an integer. It cannot take decimal values, right? So for a positive body, the transfer will be in the form of plus Ne, right? For a negative body, negative in the sense negatively charged body, we are talking about charge, positively charged body, negatively charged body, this will be minus of n times of E, right? So here n is integer, it cannot take decimal values. I hope that is understandable. One of the important method to transfer electron is frictional electricity. Now what is friction? We all know friction always happens whenever there is a contact, right? So when we are rubbing our hand, there is friction in between our hands, yes or no, right? So when two solid bodies are rubbed, then transfer of electron takes place. So by means of friction, the electrons are being transferred to another body, right? Now this happens, for example, I have two bodies, body A. Let's say I have body A, I have body B, right? So these two bodies, let's say these two bodies have been rubbing each other, right? So when they are rubbing each other, what is happening? The electrons are being transferred. This is important. Electrons are being transferred, and this transfer is what you call as frictional electricity, or you can say frictional transfer, right? So what will happen? The body A, now this transfer will happen in a body in which the electrons are loosely attached to a body in which the electrons are strongly attached, right? So that is what is going to happen. But again, it will be in the form of NE, right? Plus minus NE, integral multiple of plus minus E. The transfer will be like that. For example, let's say this is the body A. Let's say n number of electrons has been transferred to body B, right? Now what is going to happen? The total charge on body A, the total charge on body A will be simply equal to, so what happened to body A? The electrons the n number of electrons have gone to body B, right? So it will be positively charged, and the total charge on body B will be equal to minus of n times E. Now why I have written minus? Because it has gained, body B has gained n electrons, body A has lost n electrons. So when the electrons are lost, the body will become positively charged, and when the body has gained electron, it will become negatively charged. So this is what happening. So the body which loses electron will be positively charged, and the body which gains electron will be negatively charged. So in this case, as you can see, body A has lost, so it will become positively charged, and body B has gained, so it will become negatively charged, right? So these were the different properties of charge. So I hope you understood the video. So if you have any doubt, you can comment in the comment section. That's all for today. I hope you are doing good. Stay home, stay safe.